Introduction: the cosmic dance of two giants. The universe is in constant motion, with galaxies, stars, and even entire solar systems tracing paths across the great expanse of space. Among the countless galaxies in the universe, two giants in our cosmic neighborhood, the Milky Way and the Andromeda galaxy, have been locked in a slow, gravitational embrace for billions of years. The Andromeda galaxy, roughly 2 million light-years away, has long been a subject of study for astronomers. As the largest galaxy in the local group, a collection of galaxies that includes the Milky Way, Andromeda is a massive spiral galaxy that is roughly twice the size of the Milky Way, containing about 1 trillion stars. But what makes this galactic duo even more intriguing, is their inevitable collision, an event that has been predicted by scientists for decades. What was once a far-off prediction is now rapidly becoming a reality as new studies suggest that the collision may happen sooner than expected. The structure of our galaxy. To understand the implications of this cosmic collision, we must first take a closer look at the structure of our galaxy, the Milky Way. Our galaxy is a barred spiral galaxy, a type of galaxy characterized by a central bar-shaped structure composed of stars, which is surrounded by spiral arms. This spiral shape is one of the most distinctive features of the Milky Way. At the center of the Milky Way lies a supermassive black hole known as Sagittarius A, whose mass is about 4 million times that of the Sun. The gravitational pull of this black hole governs the movement of stars and other celestial bodies in the galaxy's core. The Milky Way is home to at least a few 100 billion stars, though some estimates suggest the number may be even higher. These stars orbit the galactic center at incredible speeds, up to several hundred kilometers per second, although, remarkably, it takes our Sun roughly 200 million years to complete one orbit around the galactic core. Surrounding the Milky Way's core is a vast disk filled with stars, nebulae, and interstellar dust. This is where most of the galaxy's stars are concentrated, and where new stars are constantly being born in star-forming regions, glowing with the energy of newly formed suns. Outside of this disk, the Milky Way's structure becomes even more complex. The galaxy is surrounded by a massive halo of older stars and globular clusters. These clusters are dense collections of stars, many of which are nearly as old as the galaxy itself. As astronomers study these ancient clusters, they gain valuable insights into the early formation of the Milky Way and the processes that led to its current state. Galactic collisions, a natural part of evolution. While the prospect of a galactic collision may seem alarming, it's actually a natural part of the life cycle of galaxies. Over billions of years, galaxies like the Milky Way will often pass through each other's gravitational fields, causing them to merge, collide, and even tear each other apart. These galactic mergers are not only common, but they are essential for the formation. When two galaxies collide, their individual stars generally don't collide with each other. The distances between stars are so vast that even during a collision, stars are more likely to pass by one another than to collide directly. Instead, the collision of galaxies has a profound impact on their gas and dust clouds, which can be compressed and lead to massive bursts of star formation. In the case of the Milky Way and Andromeda, when they finally collide, the resulting interaction will spark the birth of new stars as the gas clouds within both galaxies compress under the immense gravitational forces. This process of star formation will likely continue for millions of years, changing the shape and structure of both galaxies. A cosmic merger: what happens when the Milky Way meets Andromeda? As the Milky Way and Andromeda draw closer, their gravitational pull will start to influence one another in increasingly dramatic ways. Initially, their interaction will be subtle, with only slight distortions in their shapes. However, as they continue to approach, their gravitational forces will begin to stretch and distort each galaxy. In the first phase of the collision, the two galaxies will likely pass through each other in a process called a galactic flyby. During this phase, the stars and other celestial bodies will continue to follow their orbits, but the gas and dust clouds will be pulled together, triggering the formation of new stars. However, after this initial flyby, the galaxies will not simply drift apart. Instead, they will eventually begin to orbit one another. This orbital motion will eventually lead to the two galaxies merging into a single, larger galaxy. This process will take millions of years, and will completely reshape the galaxy's structures. During the merger, both galaxies will experience significant changes. The Milky Way and Andromeda will likely lose much of their spiral structure as the two galaxy disks begin to merge into a more elliptical shape. The collision will also disrupt the orbits of many stars, potentially flinging some stars into the galactic halo or even ejecting them from the merged galaxy entirely. The fate of our solar system, a journey into the unknown. One of the most fascinating aspects of the Milky Way-Andromeda collision is the fate of our own solar system. While our Sun and the stars around it will continue their orbits through the galaxy, the gravitational forces from the merging galaxies will disrupt these orbits. In the distant future, as the two galaxies merge, our solar system may be flung into a different part of the galaxy, potentially entering a region of the merged galaxy with a very different environment. There is even a possibility that our solar system could be ejected from the new galaxy entirely, sent into the dark void between galaxies. Despite these potential disruptions, there is a good chance that the Sun will survive the collision. Stars, as previously mentioned, are so far apart that direct collisions are highly unlikely. However, the changes in the interstellar environment could have profound effects on the solar system. For instance, the increased density of stars in the new galaxy could lead to an increase